Look up. Full moon. Huge. Enormous. Right there. Above the trees. Impossible. Now wait. 2 hours. Look again. Tiny. Same moon. Same night. Same distance. Nothing moved. Nothing shrank. Your camera proves it too. Same lens. Same size. Measure it and the numbers agree. 1/2 degree both times. So nothing in the sky changed. The change happened inside you, and that is only half the story. The real numbers are stranger still. Here is the fact that breaks it. The moon covers about 1/2 degree of your sky every night without exception. 1/2 degree is almost nothing. Hold your arm straight out and raise your little finger. Your fingernail is wider than the full moon. It hides the whole disk near the horizon, and it hides the whole disk directly overhead. Nothing about that changes between the two. You could stack about 180 full moons in a line from the horizon to the point straight above your head. That is how small it really is. And yet the low moon feels enormous. Some people describe it as looking twice as wide. That gap between the measurement and the feeling has a name. It is called the moon illusion, and it has been written about for well over 2,000 years. Now here's the part almost nobody expects. When the moon sits low over the rooftops, it is farther from you than when it is overhead. It is farther, not nearer. The reason is plain geometry. You are standing on a ball with a radius of about 4,000 miles. When the moon is overhead, you sit on the part of the planet turned directly toward it. When the moon is on the horizon, you have been carried around to the edge, and the whole radius of the planet is added to the trip. That extra distance is real and it is measurable. It makes the horizon moon about 1.5% smaller than the overhead moon. So the moon that looks gigantic is the smaller one. Read that again. The version your eyes swear is bigger is the version that is measurably smaller. Most people blame the air. The idea sounds reasonable. Looking toward the horizon, you stare through a far thicker slab of atmosphere. Looking straight up, your line of sight punches through the air by the shortest possible path. Toward the horizon, that same line of sight crosses roughly 40 times more air. All of that air does change the moon. It simply never makes it bigger. Air bends light. The effect is called refraction, which just means light changes direction when it crosses between materials of different density. The atmosphere grows denser the lower you go, so moonlight curves slightly on its way through. Light from the bottom edge of the disk gets lifted more than light from the top edge. The moon gets squeezed from below. Point a camera at a moon sitting right on the horizon and measure the disk. It is wider than it is tall. The atmosphere flattens the moon. It never enlarges it. The air does one more thing you can see with your own eyes. Sunlight bouncing off the lunar surface is a mix of every color your eyes can register. Air molecules scatter short blue wavelengths far more strongly than long red ones. Through 40 times more air, most of the blue is scattered out of your line of sight before it ever arrives. What survives the trip is orange and red. That is why a low moon glows like a copper coin. The color change is real. The size change is not. So if the sky is not doing it, and the air is not doing it, what is? The answer sits in how you judge distance. Your eyes never measure size directly. They measure angles. The moon fills 1/2 degree of your view, and that angle is all your eyes actually receive. To turn an angle into a size, your visual system needs one more number, and that number is distance. Feed it a small angle and a large distance, and it reports a large object. Feed it the same angle and a short distance, and it reports a small one. This works beautifully down here on the ground. A friend walking away from you shrinks in angle every second. You never once think they are physically shrinking. The correction happens automatically, using the ground, the buildings, and everything in between as a ruler. Now aim that same machinery at the night sky. There is nothing up there to measure with. No overlapping objects. No ground. no texture getting finer with distance. So the sky gets treated as a surface, and that surface is not read as a dome of even distance. It is read as a flattened ceiling. The horizon feels far away. The top of the sky feels much closer. You can hear this in ordinary speech. When clouds overhead get called low, and the very same clouds near the horizon get called distant. Now drop the moon into that flattened ceiling. Near the horizon, your visual system treats it as sitting extremely far away. Overhead, it treats the identical disk as much nearer. Same half a degree arriving at your eyes. Two different distance assumptions. Two completely different sizes reported. Far plus half a degree equals enormous. Near plus half a degree equals ordinary. That is the illusion, built entirely out of a correction that is normally correct. This explanation is old. Ptolemy wrote about the moon illusion in the 2nd century and already suspected the ground in between was involved. About 900 years later, Ibn al-Haytham worked through it far more carefully in his book on optics. He argued the effect was not in the light at all, but in how apparent distance is judged. He was pointing straight at the answer 1,000 years before anyone could photograph the moon to check it. You can test the whole thing yourself in about 10 seconds. Wait for a full moon low over the rooftops. Roll a sheet of paper into a tube and look at the moon through it. The tube strips away the horizon, the buildings, and the trees, and the disk collapses back to its true, modest size. Take the tube away, and it swells again instantly. Nothing changed except the context around it. There is another test that sounds absurd and works anyway. Turn your back to the moon, bend forward, and look at it upside down between your legs. The illusion weakens sharply. Flip the scene over, and the usual distance cues stop doing their usual job. The simplest check of all is already in your pocket. Photograph the low moon and the high moon on the same night with the same lens and the same zoom. Put the two frames side by side and measure the disks in pixels. They match, give or take that small slice of geometry. The camera carries no flattened ceiling and no assumptions, so it records the raw angle and nothing else. Here is the detail that makes all of this even stranger. The moon's distance genuinely does change across the month. Its orbit is not a circle, it is an ellipse. At its closest, it comes within about 225,000 miles, and at its farthest, it sits around 250,000. That is a real swing of about 14% in apparent width. It is the reason a full moon near its closest point gets called a supermoon. 14% is a genuine, measurable, photographable difference, and almost nobody notices it without being told in advance. So a real change of 14% slips right past you, while an imaginary change of 50% or more feels undeniable. That is worth sitting with for a moment. The measurement is quiet and the impression is loud. The moon's distance is known to extraordinary precision, and not by estimating. Apollo crews left arrays of mirrored corner reflectors on the lunar surface, and those mirrors are still working today. Observatories fire a laser pulse at them and time how long the light takes to return. At the Apache Point Observatory in New Mexico, that timing is sharp enough to pin the distance down to a few millimeters. Those measurements show the moon drifting outward by roughly 1.5 inches every year. The Lunar Reconnaissance Orbiter has been circling the moon since 2009, mapping the surface down to features a few feet across. Between the laser ranging and the orbiter, the moon's size and distance are among the best measured numbers in all of astronomy. None of that precision reaches your eyes at moonrise. The illusion is not limited to the moon either. Watch the sun go down and it swells in exactly the same way. The sun happens to cover almost exactly the same half a degree of sky as the moon, and it falls for the identical trick. Constellations do it too. Orion looks broad and heavy as it clears the horizon, then tightens as it climbs. Nothing inside any of those objects changed. only your reading of how far away the sky was. And this is happening to you constantly, far below the sky. A truck at the end of a long, straight road takes up a tiny angle and still feels enormous, because you fold the distance in without noticing. A doorway across a wide room fills a sliver of your view, and you still know exactly how it compares to your shoulders. Every waking moment, your visual system is converting angles into sizes, using its best available guess at distance. It is right almost every single time. The moon is the one case where that guess has nothing at all to stand on. So the illusion is not a flaw in your eyes. It is a correction system doing its job perfectly in the one place with no reference points, which means the moon illusion is not really about the moon. It is a live demonstration of how much of what you see is reconstruction. The light reaching you carries an angle, and nothing more than an angle. Everything else, the size, the nearness, the sheer weight of it, is assembled. Tonight, when the moon comes up over the rooftops looking impossibly large, you will know three things at once. It is half a degree wide, exactly as always. It is slightly farther from you than it will be at midnight, and the enormous version of it exists nowhere except inside your own measurement of distance. Then raise your little finger and cover the whole thing. Look up.